Imagine driving a robot scientist across the surface of Mars, steering it through a landscape that no human has ever set foot on. Every day this machine uncovers new secrets, rolling over ancient rocks and dust that have been untouched for billions of years. This is NASA's Perseverance rover, a high-tech explorer sent to unlock the mysteries of a world millions of miles from Earth. Its mission? To search for signs of ancient life and gather clues about Mars's past. In April 2025, Perseverance sent back a photo that made scientists do a double-take. Even after years of studying Mars, this image was unlike anything they'd seen before. The image showed a dark, jagged rock, completely different from its surroundings. It stood out sharply against the familiar red dust and lighter stones. The team quickly nicknamed it Skull Hill, because it resembled an ancient skull resting on the Martian soil, as if some long-lost creature had been fossilized in stone. Most rocks nearby were lighter and smoother, but Skull Hill was deep black with sharp, angular edges. Its color and shape made it look almost out of place, as if it had been dropped there from another world. Its odd appearance instantly caught the scientists' attention. They wondered what forces could have shaped such a bizarre object. When something stands out on Mars, it often holds clues to the planet's history. Unusual rocks can reveal secrets about ancient volcanoes, water flows, or even meteor impacts. Skull Hill was covered in small holes like a piece of Swiss cheese. These pits made it even more mysterious. Why did this rock have so many pits unlike the others? Could wind, water, or chemical reactions have carved them out over time? Each hole hinted at a unique story, possibly stretching back billions of years. Maybe these marks were left by ancient water, or perhaps by volcanic gases escaping as the rock cooled. Perseverance found Skull Hill on Witch Hazel Hill, perched on the rim of Jezero crater, a place rich with Martian history. Scientists believe Jezero crater was once a vast lake, fed by a river that formed a sprawling delta. This area may have been teeming with water billions of years ago. That's why this region is a prime spot to search for signs of ancient life. If Mars ever hosted living things, this is where their traces might be found. Discovering such a strange rock in this location made the find even more intriguing. It raised new questions about what forces shaped Mars's surface. Skull Hill became a new piece in the puzzle of Mars's watery past, a silent witness to the planet's dramatic changes over time. It raised questions about the planet's history and its potential to support life. Could rocks like Skull Hill hold evidence of ancient microbes? The mystery of Skull Hill was just beginning to unfold, promising new discoveries and deeper insights into the red planet's secrets. When scientists first laid eyes on the mysterious formation known as Skull Hill, their curiosity was instantly piqued. Was this strange, solitary boulder a meteorite? A rare visitor from the depths of space that had crash-landed on the Martian surface? The idea was tantalizing, and for good reason. Its dark, almost brooding color and its lonely position on the barren plain made the meteorite theory seem entirely plausible at first glance. To get to the bottom of the mystery, NASA's Perseverance rover rolled closer and deployed its SuperCam, a powerful laser instrument perched atop its mast, designed to unlock the secrets hidden within Martian rocks. The SuperCam fired a series of precise laser pulses at Skull Hill, vaporizing tiny amounts of the rock and creating a glowing plasma. By analyzing the light emitted from this plasma, scientists could determine the rock's chemical makeup with remarkable accuracy. The results were unexpected and fascinating. Skull Hill wasn't a meteorite at all. Instead, it turned out to be a volcanic rock forged in the fiery depths of Mars itself. The rock was rich in minerals like olivine and pyroxene, which not only gave it its distinctive dark hue but also hinted at a dramatic volcanic origin. Rather than being an alien object from another world, Skull Hill was a product of Mars's own turbulent volcanic history, shaped by eruptions that once reshaped the planet's surface. Intrigued by these findings, scientists developed two main theories to explain how Skull Hill came to rest in its current location. The first theory suggests that Skull Hill is a remnant of ancient lava left behind from a time when Mars was volcanically active and rivers of molten rock flowed across its surface. The second theory proposes that a massive asteroid impact blasted Skull Hill up from deep within the Martian crust, hurling it onto the surface where it now stands. Either way, Skull Hill is a silent witness to Mars's violent and dynamic geological past, shaped by forces both internal and cosmic. Its unique mineral composition and structure offer scientists a rare window into the red planet's fiery interior, and the processes that have shaped it over billions of years. The discovery of Skull Hill shifted the scientific focus away from searching for space rocks, and toward unraveling the complex geological story written in Mars's own stones. Skull Hill quickly became a key to understanding the red planet's ancient eruptions, asteroid impacts, and the forces that have sculpted its landscape. With each new clue uncovered, scientists move closer to piecing together the grand puzzle of Mars's history, one rock at a time. And as the sun sets over Skull Hill, its story, and the secrets of Mars, are still waiting to be fully revealed. With Skull Hill identified as volcanic, scientists were eager to unravel the story behind its unusual features and origins. This rock, perched alone on the Martian surface, immediately stood out to the rover's cameras. Scientists turned their attention to its mysterious holes, which seemed to hint at a dramatic past shaped by Mars's unique environment. One idea is that relentless Martian winds carrying fine dust and sharp sand battered the rock for millions of years, slowly eroding its surface and carving out the pits and hollows we see today. Another theory suggests the holes formed as gas bubbles became trapped in molten lava, then burst as the lava cooled and hardened, creating a vesicular texture. This process is common in volcanic regions on Earth, such as Hawaii, where similar rocks can be found, linking Martian geology to familiar landscapes back home. But Skull Hill is also a float rock, a rock found far from where it originally formed, hinting at a long and remarkable journey across the Martian surface. How did it travel such a distance? Scientists believe that ancient Martian rivers or catastrophic floods could have swept it away, carrying it across vast plains and depositing it far from its volcanic birthplace. This means Skull Hill might actually be a sample from a distant region, delivered to Jezero crater by the power of flowing water, long before the crater became dry and desolate. Studying this rock gives scientists a rare glimpse into parts of Mars the rover can't physically reach, offering clues about the planet's distant past and the forces that shaped its surface. In many ways, Skull Hill is a time capsule holding secrets from another place and another era, waiting to be unlocked by science. Its incredible journey across Mars adds yet another fascinating layer to the planet's complex and mysterious history, reminding us how much there is still to discover. Skull Hill is just one highlight of Perseverance's mission. Since 2021, the rover has explored Jezero crater, searching for signs of ancient life. Perseverance collects rock samples, drills cores, and analyzes dozens of targets with its instruments. The goal: gather samples for the ambitious Mars Sample Return mission. These samples could reveal if life ever existed on Mars, but bringing them home is a huge challenge. The mission faces delays and technical hurdles, so for now the samples remain sealed on Mars. They wait for a future spacecraft to retrieve them. Each tube is a treasure chest of Martian history. The hope is that one day, they'll unlock the secrets of Mars in labs on Earth. If you're fascinated by Mars exploration, smash the like button and subscribe to the channel for more amazing discoveries. While Perseverance explores Jezero, Curiosity has been busy in Gale Crater since 2012. Curiosity's mission: solve the mystery of Mars's vanished atmosphere. Billions of years ago, Mars had a thick, warm atmosphere. Now it's thin and cold. Scientists expected to find carbonate minerals which trap carbon dioxide, but they were missing. Curiosity discovered siderite, an iron carbonate, hidden in sulfate-rich rocks. This suggests Mars's carbon dioxide was locked away in the ground, not the air. As more CO2 was trapped, the planet cooled and dried out. The discovery rewrote theories about how Mars lost its water and warmth. Curiosity's findings show how Mars transformed from a wet world to a frozen desert. The search for answers continues, one rock at a time. One of Curiosity's biggest discoveries is finding organic molecules in Martian rocks. On Earth, these carbon-based molecules are the foundation of life. Curiosity's SAM instrument detected them in ancient rocks, proving Mars once had the ingredients for life. SAM also found patterns in gases like methane and carbon dioxide that change with the seasons. These patterns could hint at ancient microbial activity, but aren't definitive proof. Organic molecules can also form through non-biological processes, like reactions with sunlight. The discovery is a major step. It shows Mars had the building blocks, even if life never took hold. Scientists are cautious, knowing chemistry alone can create these molecules. Still, the findings fuel hope that Mars was once habitable. The search for life's fingerprints continues. The search for life on Mars is a story of breakthroughs and challenges. Thanks to perseverance and curiosity, we know ancient Mars had water, energy, and organic molecules. The big question: did life ever start there? Proving it requires finding something geology can't explain: a fossil, a unique molecule, or a chemical signature of life. That's why the Mars Sample Return mission is so crucial. Earth's labs can analyze Martian rocks in ways no rover can. Each sample brings us closer to an answer. For now, the rovers keep searching, adding pieces to the puzzle. Mars was once habitable. Whether it was ever inhabited remains the ultimate mystery. The answer may be waiting just beneath the next rock.